Hey, my name is Kaylee Ward, and this is my final project pseudocode presentation. I'm going to start off by explaining the beginning structure of my pseudocode versus the AI's beginning structure pseudocode. So for my self-created pseudocode, I began by declaring the function that I'll be using later in the program for case D for Cramer's rule, and included that it'll be using matrices that are 3 by 3. I also went in and declared the variables, which include the variables for the calculation choice, whether or not the user wants to restart the program, along with all the various integers and floats that are used to create and calculate the various matrix calculations. I also have a do while loop that is running throughout the program that is to continue the program until the user selects no and no longer wants to perform calculations. For the AI-generated pseudocode, it also begins by declaring the functions that will be used throughout the calculations. However, they not only have one for calculating the determinant, they also have one for obtaining the matrix elements along with printing the matrices. And then they also go in to declare the various variables that they'll be using. They include a maximum dimension constant that they use throughout the matrix multiplication. And they also create the arrays that will be used for Cramer's rule, setting them at a 3 by 3 for the matrix A and a 3 by 1 for the constant vector. So the main similarities between my beginning pseudocode and the AI's is that we both declare the determinant function initially, and we also both declare the main variables that will be used throughout the various cases that will be similar for both case B and case D. The differences is that the AI code waits until the functions themselves to declare the counting variables, and mine does that in the beginning of the script. And the AI code also uses more than one user-defined function, like the one to print the matrices or to get the user input of matrix elements. So now I'm going to get into the case B pseudocode for the matrix multiplication. So to start off, for the pseudocode that I created, I began by having a print and read operation to ask the user the row and column number for matrix A, and then having it correspond and read the row number and column number and assign it to rows A and columns A. I then repeated that for matrix B. I then used a while loop to run when B does not equal columns A. This is because for matrix multiplication, the rows in matrix B must equal the columns in matrix A, or else there's no way to properly multiply the matrices. When this while loop runs, it'll print a message stating that the matrix dimensions are unusable and that they have to retype in the values, and it'll reprompt the user to type in the row and column numbers for both matrix A and matrix B. After that, I declare and define the arrays for the matrices. I use A for matrix A and B for matrix B, and I add in the corresponding dimensions for each matrix. After that, I use a nested for loop to prompt the user to input the value of each matrix, and I go for each new line that they put in, I add the corresponding number in the array to make it easier for the user, and I repeat this for matrix B as well. I then go on to display the matrices. By doing this, I print a statement stating which is matrix A and which is matrix B, and then I use another nested for loop for each matrix to display each value of the matrix. And after each row is printed, I print out a new line so that way it's easier for the user to read. Next, I define and declare the result matrix, which I labeled as C, and I correspond the dimensions to the rows of row A and the columns of matrix B. And I do this because of the properties of matrix multiplication, where if the rows of matrix B are equal to the columns of matrix A, then the resultant matrix will have the dimensions of the rows of matrix A and the columns of matrix B. After that, I use another nested for loop to set matrix C to 0. And then to perform the multiplication, I use a triple nested for loop, including the constant k, which ties in the rows B or columns A of matrix A. And I use the dot product calculation, where for each corresponding A value is multiplied by the corresponding B value. And then after that, I print the resulting matrix, and I do another nested for loop to print each value of the matrix and print a new line for each row. So for the AI generated pseudocode, they actually begin in the case B by declaring the handle matrix multiplication function, and this is that function. The function begins by declaring the integer values row A, column A, and row B, column B. It then uses a while loop to print and read the various values from the user for the two functions, for the rows and the column numbers. It then goes in and uses an if-else statement, where if column A is not equal to row B, then it'll print out a statement asking the user to re-input the values of the matrices because they are invalid, and it will repeat if needed. It then goes on to call for the get matrix elements function for both matrix A and matrix B, which I will get into later. And once it receives the elements using those two functions, it will perform the multiplication by using a triple nested for loop. And within that triple nested loop, it sets the result matrix to 0. And then it then uses the same result matrix dot product multiplication formula that I used. And finally, it goes in and prints matrix A, matrix B, and the resultant matrix using the print matrix function. So for the get matrix elements function that it included, it prints out a statement stating to enter the matrix elements for the given matrix. It then uses a nested for loop to ask the user to print each value of the matrix, and then it ends the procedure and feeds it into the program. And for the print matrix function, it uses a nested for loop, including lines to have the traditional matrix format, and will print out each variable with spacing in between and then a new line after each row. So the main similarities between my code and the AI pseudocode is that we both use the same formula for multiplication, we both validate the size of the matrices in a similar format, and we both use a similar type of similar triple nested loop operation to find the dot product. And the main differences is that the AI pseudocode implements a function to retrieve matrix data and a function to print the matrices, while my pseudocode had those implemented within the case. And the AI pseudocode used a fixed size for each of the user input arrays, while mine uses a variable size. The AI pseudocode had a more clean printout of the matrices than I did, including the lines and some extra spacing to make it more readable for the user. So now getting into case D pseudocode for the simultaneous equations. For my self-created pseudocode, I began by defining all of the matrices that I'll be using, including A, B, dx, dy, and dz, setting all of them to a 3x3 dimension except for the constant matrix B, which I set to 3x1. I then used a nested for loop to have the user input each value for matrix A, and I repeated that for matrix B as well. I then had the program print the matrix A using another nested for loop and did the same for matrix B. I then went on to perform the calculation using my user-defined function. I set the variable d, which I'm using for determinant, equal to my Cramer's rule function for matrix A. I then went in to use a if-else statement stating that if d is equal to 0, to print out that because the matrix determinant is 0, there is no unique solution to the equation, else the program will go on to calculate the dx, dy, dz determinants along with the x, y, z variable values. For the dx determinant, I used a nested for loop stating that for each row in matrix A and each column in matrix A from 0 to I and 0 to j, when the column j is equal to 0, the constant matrix B replaces the corresponding value column in matrix dx. And for every other column, it will just be the matrix A values. I then had the determinant x, which I'm calling dx, put in and found using my Cramer's rule function based on the matrix dx. And then I repeated that for dy and dz, but using j equals 1 for dy and j equals 2 for dz. And once I found those values for dx, dy, and dz, I followed Cramer's rule to find the value of each variable by using x equals dx divided by d, y equals dy divided by d, and z equals dz divided by d. And then I had the program print the result of the calculations, printing each x, y, and z value that corresponds. For the user-defined function that I created, I began by establishing that the function is a float and is going to be utilizing a float matrix that is a 3x3 dimension. I then declared the counting integers I, j, and k along with the float determinant. I then used the determinant formula in a matrix format to calculate the determinant. The determinant formula is going to be A times EI minus FH minus B times DI minus FG plus C times DH minus EG equals a determinant. And this is in a matrix where A equals this 3x3 matrix here. And the end of the function will return the determinant and put it into the program. For the AI-generated pseudocode, it began by declaring all the 3x3 matrices needed, so matrix AX, AY, and AZ in this case, all floats. It also declared the variables that will be needed for the determinants and the solutions over here. It then went in and prompted the user to enter in each value for matrix A and matrix B using nested for loops. It then displayed the matrix A and matrix B. Matrix A is printed using the print matrix function that was defined before. And for matrix B, it uses a for loop to print out the 3x1 matrix. It then goes in to apply the Cramer's rule. It begins by calculating the determinant of matrix A by setting the determinant of A equal to the function calculate determinant of the matrix A. It then uses the if-else statement where if determinant A is equal to 0, then it'll print a statement prompting the user that the determinant of A is 0, so no unique solution exists. If that is not the case, it goes into the else statement using a nested for loop to find the AX, AY, and AZ. So it begins by setting the matrix AX, AY, and AZ all equal to the original matrix A. After that, it uses a for loop where to replace the correct column with the constant matrix B in each matrix, where matrix AX will have the first column replaced, matrix AY will have the second column replaced, and matrix AZ will have the third column replaced. It will then calculate the determinant of each of the matrices by using the calculate determinant function for each corresponding matrix, AX, AY, and AZ. And then it goes on to solve for x, y, and z by using the similar format, x equals determinant ax divided by determinant a, so on and so forth. And finally, it displays the results formatted, where x is equal to the x value, y is equal to the y value, and z is equal to the z value. So for the functions, we already went over the same function for getting matrix elements and for printing matrices. But for the function for calculating the determinant, it declares the float variable det, which will be the determinant. And then it uses the SARS rule to find the determinant and returns the determinant value to put into the program. So the main differences between the AI pseudocode and the self-made pseudocode for case D is going to be that both of them use the same logic and order with Cramer's rule to find the solutions of the variable. They both utilize a similar determinant formula and both use a user-defined function to find the determinant. But the main differences is that AI uses a different approach to find the variable matrices by solving them all together versus separately, and implementing matrix A in a slightly different way than I did. And the AI code uses a print matrix function to display the matrix, while my pseudocode uses a nested for loop within my case D versus a separate function. So finally, the final selection for which pseudocode I'm going to choose. I'm going to choose actually using a mix of both. While I prefer some of the things in my pseudocode, such as the variables and the original main wording and structure, I am going to implement some of the features that the AI pseudocode had to streamline and shorten the overall code length, so that way my code isn't overly long and complicated. For example, I'm going to be adding in a print matrix function similar to the AI pseudocode and get matrix elements, since those are operations that are used multiple times in nearly every case within the program. And I'm also going to implement the structure of how they print the matrices, adding in the lines and the spacing to make it a little more legible for the user. All right, thank you so much, and I hope you enjoyed my presentation.